Good morning to one and all, and I welcome you all back for the course on Big Data Analytics. And the topic for the today's discussion is on Big Data applications. Very interesting topic which help us to explore various use cases that is being used in social causes, government, and as well as business industries. And the outline of today's session with respect to the use cases that will be discussed, it includes related to airfare and airlines, insurance, domain of insurance, domains of healthcare, and specific things related to e-commerce, where on recommendations and management of weblogs and HR management, again an industry specific use case. So HR management is something related to business domain of management. Recommendation and weblogs is something related to domain of sales, marketing, product management, production. Healthcare epidemics, it gives us an overall scenario of managing healthcare using big data technology. And again, insurance, it deals with traffic analysis, risk analysis and customer management. So we will be discussing all these use cases in continuation of the session. And now, as usual, right, we have to go for the recap of the session because we are on the last day of the session, and hence again to have the mind map of all the concepts, whatever we have discussed so far in this topic is very essential to have or to understand the use cases related to big data. And shall we start with the first day of the recap? So we have started with data. Now we know that data, it is as an important value component which drives the business and business scenarios. So since data has become the driving force and become the driving force of the digital platform, it has so much of added value, and this data is become so voluminous, exponential, and generated tremendously, leading to a term called as big data. And when we look back about what made this to happen suddenly, or this exponential rise of large volume of data, when we look in, we can find out there are all competing technologies slowly has driven data into a fuel to drive the business economy, or we are in the data economy where data is the driving force. So when we look on all those technologies, where social media, after the advent of social media in 2010, with all other technologies of database management, internet, and all other techniques such as data mining, data warehouse, and business applications, customer relationship management, MIS, and all knowledge management, all these things together made data to move to rise to an exponential value. So social media platforms, as it provide the simplicity and it provided the pace for the end users, human beings and people to share and register their opinion. It has bring in lot of users to get into the digital platform, which was a major reason of getting this voluminous amount of data. This is what we have discussed, and we have seen how much of data sources has been populated within a very short span of time. And most of unstructured data is being generated, with 90% of data leaving the digital space and 10% of data from the business domains. And when we look into the big data perspective, the definition of big data, and we have found that big data is a tool, is a technology and a platform used for identifying the hidden insights that is in the data by using distributed architectures and parallel processing model to deal with huge amount of data. We have also come out with the myths, whatever we have big data, and come to a conclusion what we do actually called as big data and where big data can be applied. And we also seen the use cases. Again, we will be discussing with respect to that. So again, we have a fast recap about it. So the use cases of big data, we call it as the first use case, it is about having data exploration, understanding what happened in the business, And second one, it is 360-degree view of customers, operation analysis, risk management, and data warehouse augmentation to the 5 major use cases. And when we discuss about your technology perspective, we discuss about the technology, the limitation of the existing system. So limitation of the existing system, it is of because of storage, processing, and your scalability. This three things made the existing architectures unable to fit in this large volume of data that is being generated in the digital space. So there become a necessity of an alternate source where big data came into picture, and we have discussed about the big data platforms, Hadoop and Spark. So when we say about Hadoop, it's a distributed system based on your parallel programming model. It is a combination of two different concepts of distributed computing and parallel computing. And when we talk about Hadoop, one thing that makes it different from other thing, it brings in computation to the data rather than making data to move towards computation. That is the simplicity of the Hadoop model, and it works for a batch processing model. Again, to overcome that Hadoop limitation, Hadoop 2.0 was been put in, where other components can be added into it. Spark also we discussed in tools, the other different platforms, different skill set, and all those things. Again, we'll have a detailed recap at the end of the session, not moving towards that. Shall we move into the session of big data use cases? Use cases is nothing but we call it as applications. And the first application that we are going to deal with, it is going to be airlines. Airlines and big data a glance. So where does this use case of airlines fit into? As I said you that this big data use case is being fit into this 5 major classification, where we can group in and pull in with all other related data. So exploratory analytics, customer analysis, operational analysis, and data warehouse augmentation, risk and security are the major things we are going to deal with airline big data at a glance. And now we move into the objective of the use case as well. Hike of airfare based on high value customers, right? So before getting into an airfare management, so the first important thing we have to discuss with the data related to airfare are what are all the data sources that contribute or that are related to the business domain. That is very, very important. And the core objective it is what information we have to find it with this amount of data. That is very, very essential. Identifying data sources and what is the hidden insight we would like to have, at least an abstract view is very essential, even though we could not arrive the concrete solution, because again the data is huge pool generated for a longer period of time. It is very difficult to get in concrete what we are looking in for, where sometimes it is possible. So what decision we want to take and what we want to analyze, an abstract view is very, very important and essential. So when we look in, so first we have to look in about the data sources. So what data sources, when we say it is airline, it has been related. So when we look on to the data sources, normally the data source consists of the conventional ERP system where all airways or airline deals with. It includes ticket reservations, ticket booking, flight details, flight maintenance, and flight employee maintenance, all other things that has been coming in. This is all the structured data that will be generated from the ERP enterprise information of airline reservation system. And apart from that, what data as we generate, as we are data generators, so anything with respect to airlines, we do may give our feedbacks in blogs, social medias, and we do compare our pricing and give our ratings of different, and we put our likes on Facebooks and share our opinions with respect to the customer care, service, and maintenance aspects that is being given in aircare, which is again which is customer centric. Now when some decision has to be taken up with airline, so understanding of the data insight. So when the company, when the organization of airlines want to come out with some specific insight about, because it is very, very essential, because flying a flight airway is not so easy. It involves more cost in it. So again, it was to find out some information with respect to customers, because without customers, doing something with flight information strategic decision is impossible. So we'll make it as an inline that what are the customer insights that we would like to infer from the large pool of data that has been generated. The first question, it will be, how are my customers divided? Where will be, from which part of the place my customers come in, and what are the customers my booking? Because we have different classification of airline booking as economy class, business class, and so many things. So how are the customers are divided in general, and wow, which customer is my customer who always retains with me, who is a high value customer, and who is my frequent flyer, who uses my flight frequently, and how do I retain customer? Retention of customers is very, very important in all business domains, right? So this is what is the insight that has been required with large pool of data that has been generated from all these data sources with respect to business. So when we look on to that, so whenever we go into big data, so we have to have a brief thought about the data sources. And when we look on the data sources, we have to think about what will be my existing business relevant enterprise data sources, data stored in databases or in data warehouse. And then we have to think about what is the unstructured data that can be pulled out as an external data source relevant to the business that has been available. So again, that has to be bring in. So because this is the pooling that help us to do lot of things with respect to the use cases. And once we look into to this particular information, suppose we want to classify the ASA, we have going for data engineering, analyzing the data, building upon data, architecting upon data, and coming to a conclusion. When we look on to airfare classification, so we look on, and there are different classification: airfare, economy class, business class, and first class. How do we analyze it? So we have to do a detailed analytics part. In analytics methodology, we call it as EDA, data exploration. This is our first use case. Find out what is available in my data, what has happened in my data so far in the business for a longer period of time that has been retained, and what is the ROI, return of investment, this data has to bring back to the business, which is very, very important. This is what is the insight that would be gathered. So we'll be looking on passenger booking information, look on the forecasted data, all the inventory, all these information is very, very essential to find out the customers who occupies my economy class, looking on his business class, first class, and then mapping it with whether these customers are in line with my social media platform, they do provide with any feedbacks, or they do provide my rating or recommendation, right? So all these information is very, very quite essential. Then apart from that, we also collect data about the customer behavioral data in order to predict whether this customer will be with me, this customer will be flying in always my flyer, or he will be opting for a different flyer, or what was his travel history, and what were the different type of flights other airlines he has taken and not taking my airline, or not taking airline A or B. So all those things, it can be correlated and pulled out from the unstructured data from websites which provides the routing information, and also can be help us to find out the dining preferences, what dining they prefer. Again, it gives me an insight. Why does the customer always, so that does dining what he do, it has a reflection over it. Again, all those information is very important. And apart from that, again, analyzing the data from social profiles. So social profiles is from your social media data with respect to his comment on service, is with respect to comment on flight delays, and all those things has to be taken. So engineering of your data, walking through all the parts of data, as well as we should have a feel that we do walk into all pictures of data, or the heights of data and the lower points of data, to find out what has been hidden inside the data just by rotating the data, as a globe in a 360-degree rotation. So this we call it as data engineering. So once we've identified the data sources, then second we have to find out what I can find out from the insights from this data. This is where your analytics part comes in. And this is what we call it as 360-degree view of data. Understanding what is being available, it is we call it as data exploration. So these are the two use cases. And again, we do with large pool of data collected from different data sources. We need a big data platform to do all those things. And where are the challenges that comes in? The data is larger than terabytes, and integration of data from various sources, and data is in different formats. So why data in different formats is a very simple example. See, nowadays we don't communicate our emotions or our opinions just by saying something in words. We just stick on some of our emojis or smileys and put on our social media platforms to share our likes. So now it is very difficult for the people to understand what is the view of the customer about it, whether he likes it or whether he doesn't like it. So we have algorithms such as opinion mining and sentiment analysis, which is exclusively to understand the customer 360-degree view. So again, that has to be considered as variety of data format. So in order to find out all these things in an airline reservation or something, what data we want, how do we manage, what is being required to manage. Now we have to look on. So we know the data sources, and we know that the data is voluminous in nature. Data has the characteristics of variety, and data is streaming in nature because social media data, the frequent flyers will be providing their things. So how far this data is valid? Say some customer who would have given me the comment long back about the hike of airfare, should I take into consideration even after a year back? Is he continuing as my customer, even taking my flyer, or he has moved into a different flyer? So what is the validity of this customer, and how far he is able to give it? Is this customer, is this data a value component? So all these characteristics come once again as a chain when we pull out the data. So we have come out with the data characteristics, we have come out and we have identified what are the use cases. So now we have to analyze from the operational analysis. So when my customer books a ticket, from which places he frequently travel, right? So what is it? How do we take the data? What is his travel history? What does he prefer? All those informations are very important, which are again fit into our data characteristics. So once we begin, now we have a very much of raw information in front of us. Now I have structured data, we have unstructured data, and we have so many data integration components coming in. Now, how do I integrate this data is the second question that comes in. And this is where big data comes as a solution. How big data provides us a solution? Because all these things, even when we collected, it leads to an issue of storage, processing, and scalability. Scalability is a very biggest challenge of your business concern. So to overcome these issues, we have three important accelerated components. Hadoop ecosystem. We can set up ecosystem to pull in all these integrated data. Since we have a model of an horizontal scaling, scalability is not an issue. Processing is also not an issue because we move computation to the data, not data to the computation. That is again a very important thing. And again, integration of data warehouse, augmenting data warehouse is also very easier when we go along with this particular information. So all these things can be addressed by using this solution. We call it as big data accelerators. And this is a source that is being taken by Big Data Spectrum by Infosys from the industrial use case for the presentation. And I hereby cite them and acknowledge the magazine Big Data Spectrum of Infosys. I think now we are very clear, right? How to model an use case, or how to analyze a use case to check in whether it fits into big data, what ecosystem I need, whether I need a Spark ecosystem or whether I need a Storm, or we need a Zookeeper, whether what type of NoSQL data models I needed, whether we need a graph-based model or we need a MongoDB document store or something. All those things can be made very quite clear with this example. So big data is a solution, what it fits in. And when we look in it, it addresses all the 5 use cases. Is it or not? Managing my customers, Identifying the security risk is also again one thing, right? So how does my customer, again with respect to other thing, again the other data which we have not left out is operational analysis, the data that has been let out by aircraft during the maintenance, the fuel expenses, and the data that has been shared by the aircrafts, all those things that has to be considered. We call it as operational efficiency. Okay. And I think we are very clear with that. Now, shall we move on to the next domain to understand the insurance risk analysis? Yes. Now I want you to just think of something related with the insurance. What comes into your mind when you think something called as insurance? Yes, insurance is very important. It's a very important domain. And we know that the more data we pile up in insurance, where a structured data, we have discussed this example, we pay insurance policies only monthly, or we do it as bi-monthly, or we do it as quarterly, half-yearly. We do have insurance for all. We have for houses, we have for our vehicles, we have our medical insurance policies, we have our medical policies for our pets, your animals, cattle, and so many things are there, right? Even for agriculture, there are insurance policies. Now, what would we like to use big data analytics for risk analysis? Why most on risk analysis, not on understanding my customer? Whether my customer it is. So here I could not have my 360-degree view of my customer, right? So what is the core we can understand from the risk analysis, whether the customer will be continuing or this customer will pay the premium or not. That is a very important, right? So how many customers pay for a while and they leave? What is the reason why they don't do look in? Why do they stop an insurance premium continuing for 2 months, and why do they stop for the third month? What is the reason behind it? And do I have any chain of link about it? Or how many of them are shifted from one policy to other policy? What type of policies they prefer? All these things has to be understood again with respect to the insurance domain. Now we just have narrowed down our analytic scenario, your use case scenario for fraud detection, the use case scenario. Now the first thing whenever we think of, then we have to think of the data sources. So when we think of the data sources, where we'll get data for insurance? Quite more data comes only from the business component of the insurance domain. So the insurance data is stored in ERP systems. Where do we pay our insurance policies? Then where do we get other information? Credit history from other sources, right? What is our credit history? Normally CIBIL, it gives us our credit history, right? What is our financial transaction? What is the strength of the financial transaction of the customer before we go in for any loan? Again, that is again very important for your insurance sector also, right? So data about customers, the products that is being sold of different policies from enterprise resource management, and the services, how do the customers pay from CRM systems, inquiries that has been made, all those things. Then where do we come? So data from social networking. Again, this unstructured data source has to be blended, right? So what unstructured data source can be blended? So we have to look of the product rating and the credit rating from third parties. How do the third parties rate a particular insurance policies? Because this is related to finance. So many experts in finance and other other people who are strong enough, they do recommend a particular product to large number of customers or insurance holders, right? Again, their rating plays a very important role before someone seeks or to find out a particular insurance policy. So we have to look about data about all these things. Again, what are my structured data sources? What are my unstructured data sources? Once we are clear with that, then we have to think about volume of data. Is it very important? Should I go for a big data platform or a big data analytic perspective? Or what insights we have, or we require a big data platform, Hadoop, or I can do it with a programming language such as R and Python. That is suffice. So that is again to be Then once these parts has been very much clarified, then we have to look on the engineering of your data. Where will I like to data? So what data has to be looking again, because I could not say my system to just pull in and just bring in, right? Again, we should have a clear idea, right? What data has to be integrated and provided into my system to do an analytics part or to do a prediction part. If not, we could not pull in, push up all unrelated data and make it as a mess. That is not possible. Again, we should have at least a thin line of concretion before providing some inputs to the system to do a processing. So what is the data engineering required? So it requires verifying customer data, analysis of customer profiles, verification of claims raised, fraud reduction, exact claim reimbursement, because in insurance most of the risk it is with fraud reduction. So how many times a customer has paid the insurance policies, how many times he has claimed the insurance policy, is it for vehicle or is it for something else, what is the frequent it has been done, or it is for individual hospital medical expenses. So all those things that has been done. And again, we have to find out how many claims he has been raised. Is a real customer, is a claim verification is appropriate or not? Yes. So now that again some interesting story behind this I would like to share. See, now the insurance companies has been put up into smart cars. So no more insurance companies validate only with data. Then now they would like to take data with what? From the IoT devices, from the machines. Now my car is my machine. When with respect to vehicle insurance, we look at a case scenario. Now most of the time we go in for vehicle insurance for reimbursement, right? Because accidents normally take place, we go for vehicle insurance. Earlier the data will be verified and then the claims will be submitted and then it will be reimbursed and verification takes place. Now systems has become very smart and towards digitization. Now what happened is, see, now IoT plays a dominant role in big data. So anywhere data comes in, big data is the platform. So wherever this data has to be kept, then only we can do any of your prediction using the algorithm. So IoT gadgets, now in smart cars, they put in sensors to check in whether the driver drives with a sleeping pattern, or whether the driver has consumed liquor or anything else. What is his driving speed? What is his accelerated speed? Whether the driver is in a sleepy mode based on his iris signal, whether the driver has been with a he has a temperature rise or he's with any health alignments. So we have all these features embedded in the cars, IoT based smart cars, where you have a heart temperature sensor, you have your iris recognition camera sensor which sends data, right? Again, that help the customer or the insurers to find out, right? When a customer has made an accident because of a sleepless night, easily the system will gives you the information, because the data from this IoT is being pulled in, that again can be given it to the insurance holder for verification. So they may not give you the they may verify the claim with machine generated data. You're clear with it? So now insurance, now it has been related with IoT devices also. So now machine generated data is also very, very important. So operational analysis for insurance sector, it comes from machines, all IoT devices, right? Now I could not say that because of this, even in agriculture we have moved to smart planting systems and smart agriculture system. So in futuristic perspective, every accidents or everything that could be easily found out because of our IoT based data that is going to get generated, and that is why we say that we are in an era of Internet of Things. And with this, before getting into health epidemics, let us find out. Now we have pulled out what has to be identified, what data sources can be come in, and verification of claim rise. So what is the system we have? Do we have streaming data here? There is very less of streaming data unless IoT data of all vehicles has been connected. Once it is being connected, then that data, it is also, even the overspeed is also been to take into consideration. Now smart cameras has been put on roads to find out which customer violates traffic rule. Again, that data will be added for your insurance sector, right? Where highways, all people have employed with very high density cameras which capture images saying he violates the traffic rules, and when he makes accident, that is again used for traffic rule regulation by police officials. just making a fine on them, imposing a fine on them. All these things again add values to the insurer, right? So all these things, right? This customer is a risky customer, all these things. So now, do we need a streaming data? It is a question. No, streaming data is going to be very less in nature. So it is again to be a batch related Hadoop base. Yes, Hadoop base OS. When I need IoT devices, then I need a streaming architecture. What it should be needed, whether I need a Storm or I need a Spark, and where my devices comes in. So all those inputs can be made. So for insurance sector, again, what use cases comes in? A thorough analysis of the existing data, understanding the customer with 360-degree, analyzing his claims, analyzing his returns, analyzing his profiles, analyzing his social media, ratings of a particular insurance policies, and all the things, it becomes very, very essential. Then what else it has been required? So data warehouse augmentation also it has been required. So how do we combine with so many other data? Credit history has to be combined, ERP has to be combined, because insurance, the customer will not be continuously doing it. Many of the customers, they pay for a month, and many of them, they do leave it due to lot of reasons. Again, finding out, seeking the reason why it is, all those things are very, very quite essential. Again, we need a thorough analysis of it. When IoT data is being generated, we need some operational analysis generated from machines. That is, then data warehouse augmentation is also required to understand the entire data, to pull the entire data related to insurance sector. Again, this is again an important, interesting field where most of the organization, they use SaaS. All financial, the people work on SaaS as the software. SaaS as Hadoop has been enabled, which provides beautiful analytics. So again, a commercial tool of SaaS has been used. So anybody within big data, then we have to analyze the data analytic procedures and methodologies to work in the SaaS modules.